Assalamu alaikum warahmatullahi wabarakatuh. This is going to be our third lesson in Organic Chemistry 2 in Form 4 work. Subtopic, detergents. What does the word detergent refers to? In daily life, we use detergents every now and again. In our houses, we have the detergent. So what does detergent refers to? We say a detergent is any substance that is being used to improve the cleaning property of water. So any substance used, a detergent is a substance used to improve the cleaning property of water. So that is what we refer to as a detergent. So if I can just give a brief example of what we are referring to as a detergent, we have the soap that we use in our houses, we have the bar soap, we have the powdered one, we have those ones which are in liquids. So all these things is what refer to as the detergents. And when we talk about the detergents, detergents are of two types. So we have here types of detergents. Types of detergents. Under the types of detergents, we have two types of detergents. That is soapy detergent and the soapless detergents. So we have the first one, we have soapy detergent. The second one is soapless detergent. Those are the two types of detergents that we are having. If we first have a look at soapy detergents, we have soapy detergents. Soapy detergents, these are made from fats and oils obtained from animals and plants, are made from fats and oils obtained from animals and plants. So we have fats. Fats are saturated and obtained from the animals. We have the oils, which are unsaturated, being obtained from the plants. So they have these fats and oils, they contain what to talk about fatty acids, because we know that the building units of lipids, because the fats here and oils are falling under the lipids, and the building units of lipids is the fatty acids and the glycerol. So we are interested on the acidic part where we have the fatty acids. So the general formula of this one here is going to be CnH2n plus 1 COOH, the carboxylic acids that they are having. So we talk about this one here as the carboxylic acids that we obtain from the fatty acids, from the fats and oils. So the oils and fats are going to be heated in concentrated alkali. So we say that fats stroke oils are heated in concentrated alkali. The concentrated alkali here can be sodium hydroxide or potassium hydroxide, forming the soap and glycerols, because they contain glycerol also. So the process here is referred to as saponification. This process is known as saponification. So saponification is the process of heating fats or oils in concentrated alkali in order for us to be able to make the soaps. So after carrying out that process, there is a process known as salting out. Salting out. So a process known as salting out is then done. Where sodium chloride is added. Sodium chloride crystals is added to precipitate the soap. So we are going to precipitate the soap so that it forms the solid, then we remove it. After the removal, then now we can clean it using water in order to remove the glycerols. So we have here the fat stroke. We have here the fat stroke the oil plus the sodium hydroxide alkali plus the alkali, concentrated alkali, which can be sodium hydroxide. This gives us the soap plus glycerol. Soap plus the glycerol. So this process is talked about as the saponification. Now what is going to happen? We now add sodium chloride crystals. After addition of sodium chloride crystals, the process is referred to as salting out. It is known as the salting out. We are carrying salting out to lower the solubility of the soap. Therefore, the soap is going to form the solid. It's going to precipitate. Then we remove it. We are going to remove that soap. So now the general equation, what we're going to have, we have RCOOH, where R here represents the hydrocarbon part. R represents the hydrocarbon part. So this is an organic acid. We have here H. This one may be in liquid state plus the concentrated alkali, which is sodium hydroxide, giving us RCOONA. This is positive, this is negative, plus the H2O. So this is the soap. This is the soap that we are talking about. Now, it contains the carboxylate part. Now, the overall representation, meaning that a soapy detergent is made of two parts. We have the polar part and the non-polar part. The polar part is where we have the charge, the carboxylate part and the sodium ions. It contains both partially positive and partially negative. And we also have the hydrocarbon part, which is non-polar. So we say that a soapy detergent, a detergent is made of two parts. It's made of two parts. The polar part, and into bracket the head, and non-polar part into bracket the tail. So the overall representation here, we have this. So this is what you have as the polar end. This one here represents the non-polar, which is represented by R. So the head here represents this part that we are going to have. So we say that a detergent is made of two parts. We have the polar part and the non-polar part. Now let's have a look at the mode of action of a detergent. Mode of action of a detergent. Mode of action of a detergent. Mode of action of a detergent on a dart. On a dart. Into bracket grease. Now, when you want to clean the grease, water alone cannot be used in the cleaning of the grease. For example, if maybe you are cooking and you have touched some oil in your hands, or you are in a workshop like the mechanics, they are your hands will get dirt, especially the oil, and you want to clean off. You want to clean off, or you want to remove the dirt. So if you get water alone to clean off that grease, or even when you are in the kitchen, you want to remove the oil in your hands, you will find that water alone will not be able to remove that oil. In fact, when you try to clean, your hands will just be sliding. That oil will only be spreading on the hands. So what you do, you need a detergent like a soap so that you can be able to clean it off. This is because grease is non-polar and it is insoluble in water. So since grease is insoluble in water, that's why we cannot be able to clean grease using water alone. So if you use now the soap, which is a detergent here, it is made of two parts. We have the polar part and the non-polar part. So the polar part is said to be hydrophilic, while the non-polar part is said to be hydrophobic. When we say that you are hydrophobic, means that is water hating, someone who doesn't like water. So maybe let me talk about in a month, you only take a shower at the end of the month, only once. So we say that you are hydrophobic to water. So the same thing happens here. So here we are going to have the hydrophobic part and the hydrophilic part. The part which is non-polar is hydrophobic. It does not need water. Therefore, the part which is hydrophobic is going to attach itself to the grease, while the hydrophilic part, which is water-loving, attaches itself to the water surface. So this part attaches itself to the grease, and this part attaches itself to water molecules. Therefore, what is going to happen is that due to the agitation being made on the cloth that is going to be cleaned, so that coagulation that is going to be made between the molecules. So this detergent is going to form some spoke. You find that it attaches itself in a form that, so before that we say that a detergent, a soap, is made of non-polar part, which is hydrophobic and attaches itself to the grease, while the polar part, which is hydrophilic attaches itself to the water surface. It attaches itself to the water surface. So we have said that the hydrophobic means water hating, hydrophilic means water loving. So if this is the substance that maybe you are cleaning off, we have this as what we are cleaning off. Then we have the grease here. This is grease. So we have those ones representing the So that's what we're going to have. So this one represents the detergent. This is water. This one represents detergent. And this one represents the grease that we are cleaning off. The grease that we are cleaning off. So the non-polar part, which is the hydrocarbon part, has attached itself to the grease, and the polar part has attached itself to the water molecule. So due to that agitation, and there's going to be charges that's going to be developed. This one has both positive and the negative charge, and the water molecules also has a positive and the negative charge, meaning that as a result, there is going to be repulsion, which is going to prevent these detergents, some of the molecules, coming together. So due to that, as that force continues to apply, you will find that at the end, if that is what we are cleaning off, we find that this is what now we are going to have. We are going to have the grease there. So these ones now are that is what we're going to have. And this one here represents the water molecule. So this one is before, and this one is after the cleaning. So the dirt comes with the detergent on the water surface, with the hydrophobic part attaching itself to the grease, and the hydrophilic part attaching itself to the water surface. So you can see that we have already cleaned that container, and it is now free from grease that we are having. So that gives us the mode of action, meaning if you can be asked to describe the mode of action of a detergent, of a soapy detergent on grease or on a dirt, you must be able to talk about the hydrophobic part and the hydrophilic part, knowing between the two parts which one attaches itself on the water surface and which one attaches itself to the water molecule. So during that process, and as the washing takes place and the charges also being developed, making the detergent to come off with the dirt or the grease on the water surface, as we have just seen. Now the material, whatever that we were cleaning, will now going to be clean. Now, we also check on what is the effect of a soapy detergent on hard water. Effect of a soapy detergent on hard water. Effect of a soapy detergent on hard water. The effect of a soapy detergent on hard water, and before I talk about hard water is that water which contains calcium or the magnesium ions, which are the responsible for water hardness. So what happens is, when you are using a soapy detergent with hard water, there is formation of scum. Scum is just an insoluble salt, so a precipitate is going to be formed. That precipitate is what we talk about as the scum. So for example, the overall representation of a soapy detergent is RCOONA. This one here is positive, this one here is negative. Then we are adding here hard water which contains the calcium ions. So what is going to happen is that the sodium ions are going to be replaced by the calcium ions. So we are trying to precipitate the calcium ions in that water so that we can able to soften it. So we are going to get RCOO into bracket here 2, then Ca, solid plus Na positive aqueous. So this is what we talk about as the scum. This is the scum. This is 2. So this is what we have as the scum. So we have here an insoluble salt being formed, known as the scum. So that gives us the effect of a soapy detergent on hard water. Effect of a soapy detergent on hard water. Now, our next part, we move to soapless detergents. Soapless detergents. Soapless detergents. So when you talk about the soapless detergents, the hydrocarbon part under the soapless detergents are obtained from crude oil. We obtain them from the crude oil. So we now check on soapless detergents. Soapless detergents. The soapless detergents are distinguished from the soapy detergents by the sulfonate part. So the overall representation of this one here is ROSO3Na, positive, negative. So these ones have the sulfonate parts, but these ones were having the carboxylate part. This is the overall representation of the soapless detergents. How are the soapless detergents being formed? So we say the hydrocarbon part is obtained from crude oil. So the hydrocarbon part, into bracket, we talk about the alkyls. So the alkyl being formed is going to be reacted with a benzene ring. So alkyl is reacted with the benzene ring. Alkyl is reacted with benzene ring to form alkyl benzene. We get alkyl benzene. So we are going to have here, so we have said that the R here is representing the hydrocarbon part. So the hydrocarbon part, which is the alkyl R, plus the benzene ring, we react it with the benzene ring. We get, this is an alkyl, this is a benzene ring, giving us R. We call this one as alkyl benzene. We have an alkyl benzene. Then the alkyl benzene formed is going to be heated in concentrated sulfuric 6 acid. So alkyl benzene is reacted with concentrated sulfuric 6 acid. Alkyl benzene is then reacted with concentrated sulfuric 6 acid. Sulfuric 6 acid to form alkyl benzene sulfonate. Alkyl benzene sulfonate. So we are going to have now R plus H2SO4 liquid, giving us ROSO3H. This is known as alkyl benzene sulfonate. So we have already introduced the sulfonate coming from sulfuric 6 acid. We have already introduced the sulfonate part, which is OSO3H. Now, the alkyl benzene sulfonate is then going to be reacted with concentrated alkali. Alkyl benzene sulfonate, alkyl benzene sulfonate is then reacted with concentrated alkali to obtain soapless detergents. To obtain the soapless detergent. So we are now going to have OSO3H. This one here is we reacting it with OH, giving us ROSO3Na. This one here is positive, this is negative. So this is the product. This one here is giving us the soapless detergent. This is the soapless detergent that we are going to have. Then, after the formation of this, the difference between a soapy detergent and the soapless detergent is that this one forms scum with hard water. That's the effect of a soapy detergent on hard water. But a soapless detergent does not form scum with the hard water. Why is this so? This is because after the formation or after the preparation of this detergent, there is other substances that is being added into this one here, so that when being used, it cannot form a precipitate with the calcium or the magnesium ion. And the substance being added is known as tetraoxosulfonate. It is known as tetraoxosulfonate. So we say that tetraoxosulfonate is then added, tetraoxosulfonate is then added to the detergent, so that it doesn't form scum with hard water. It doesn't form scum with the hard water. In fact, now that gives us the reason why places where we are having the hard water, you will find that in most cases they will be using the Omo. So example of a soapless detergent is Omo, we have Ariel, we have Toss. So examples of soapless detergents, talk about examples of soapless detergents. Soapless detergents are, we have Omo, we have Ariel, don't know if that's the spelling, we have Ariel, we have Sunlight, we have Toss. So those gives us some of the examples of the soapless detergent. And an example of a soapy detergent is the bar soap. The bar soap. We have Jamaa, we have Panga, we have Menengai, we have Lido, we have Lifebuoy, we have Geisha. Those ones are examples of a soapy detergent. But examples of the soapless detergents are this one. And we have said that the differences between a soapy detergent and the soapless detergent, a soapy detergent we add what we call tetraoxosulfonate is being added. This is to prevent the formation of scum when being used with hard water. And places whereby we have hard water, you will find such kind of areas, people mainly use soapless detergents like Omo. They use Omo because it forms leather easily with hard water. While if you use this one, it is going to result into the wastage of the soap, since it will first need to precipitate the calcium or the magnesium ions. After the precipitation of the calcium or the magnesium ions in the process forming the scum, that is when now it can be able to form the leather, so that cleaning can be more easier. So let's have a look at some of the advantages of a soapless detergents over the soapless detergents. So we have here soapy detergent, advantages of soapy detergent. So we have soapy detergent. This side we can have soapless detergents. One that we can talk about, the first one, under the soapy detergent, advantage of this forms scum with hard water, hence wastage. This one does not form scum, doesn't form scum with hard water. So you can see That is one of the difference between a soapy detergent and a soapless detergent. So if you are living in a place where there is hard water, it is more preferable that you use a soapless detergent when carrying out cleaning. Then the second one, soapy detergents are made from fats and oils, and we know that fats and oils can undergo decomposition, while these ones are made from the long chain alkanes. That's where we obtain the alkyl group, which means this one are going to be non-biodegradable, which means they cause environmental pollution since they do not undergo decomposition, while these ones here are biodegradable. They are biodegradable, they can undergo decomposition. Then another one is, these ones here are cheap, while these ones here are expensive. They are expensive. So that is also another differences. The bar soap, you can even buy a bar soap of 5 shillings. We have those ones which are being sold maybe at 5 shillings. But in these ones here, they are very expensive. I think the lowest one is maybe around 15 shillings, if I can talk about the Omo, depending on the size or the grams. Then another one that we can talk about under the advantage and disadvantage. So the fourth one, this one here forms stain on white clothes when used with hard water. So forms stain on white clothes when used with hard water. This one here does not form stain when used with hard water. So those two, this one here gives us some of the differences, advantages and disadvantages of a soapy detergent and a soapless detergent. So from the two, you can be able to distinguish a soapy detergent and a soapless detergent from looking at the soapless detergents are containing the sulfonate part, while a soapy detergent contains the carboxylate part derived from organic carboxylic acids, while here the sulfonate part is derived from sulfuric 6 acid. Therefore, that marks the end of the third lesson of our topic. And the fourth lesson, which is going to be the last topic of organic chemistry 2, is going to be on polymers. That will mark also the end of that chapter of organic chemistry 2. Thank you so much.